What is the role of cooling in deep-sea mechanical engineering? Imagine being able to use the ocean's own chill to keep machines cool in the depths of the sea. That's exactly what deep-sea mechanical engineering aims to do. It's all about managing heat in environments where traditional cooling methods just don't work well. The deep ocean offers a very stable, cold environment, usually between 3 and 8 degrees Celsius. This makes it perfect as a natural heat sink. Instead of relying on electricity-hungry air conditioners or chillers, engineers use the cold seawater to absorb heat from systems on ships, underwater facilities, or even offshore oil platforms. The main idea is to transfer heat from a mechanical system to the cold seawater through devices called heat exchangers. These heat exchangers are specially designed to let heat pass from the hot side, like machinery or building fluids, to the cold seawater without mixing the two. Materials like titanium are often used because they resist corrosion and fouling caused by seawater. This process is very efficient because it uses the ocean's natural temperature difference to cool equipment. It can cut down energy use by up to 90% compared to traditional cooling systems. That means less electricity, lower costs, and less impact on the environment. To make this work, cold seawater is pumped from several hundred meters below the surface through pipelines that are built to withstand high pressure and corrosion. Once the seawater flows through the heat exchangers and cools the fluids inside the system, it is then returned to the ocean at a depth that minimizes environmental disturbance. This setup is used in many practical ways. For example, coastal cities and resorts use it for district cooling, which cools large areas efficiently. Industrial plants that generate a lot of heat also benefit by improving their efficiency and reducing their carbon footprint. Sometimes, these systems are combined with desalination plants, helping to lower energy costs for producing fresh water. Of course, there are challenges. Installing deep water pipelines and pumps is costly and complex. They need to be reliable and safe for the environment. Still, successful projects in tropical resorts and university campuses show it's a feasible and smart way to cool systems. In the end, using the ocean's natural cold water as a heat sink is a smart move. It helps reduce energy use, lowers operating costs, and minimizes environmental impact. This approach is a perfect example of how heat transfer principles and smart design can turn the ocean into a giant, renewable cooling resource.